Okay, so welcome to lecture 12. I'm recording this because I couldn't make it last Friday. I'm gonna put these videos on YouTube. You can have access to them, but I think I'm gonna delete them probably a couple of weeks from now or something once I feel that people have already gone through this material and there is no need for the videos anymore. So we're going to talk about lexical semantics. This is lecture 12. I'm going to break it into many small videos just because if I make a mistake or I sneeze or something, I don't have to start all over 20 minutes or something like that. This is video 1. Lexical semantics is concerned about how can you infer the semantics of a word from the lexical context in which it appears, and this is what we're going to talk about. So we can start with an example. There are many words that probably are not very popular right here, unless you have seen this passage before. So if we read this little poem, it says something like, beware the Jabberwock. So it is the first word, Jabberwock. What is a Jabberwock? Beware the Jabberwock, my son. The jaws that bite, the claws that catch. Beware the Jubjub bird and the frumious bandersnatch. All right, so if we just focus on the Jabberwock word and we try to infer what it is, so probably we can take a look at words like jaws. It has jaws, it has claws, right? It is something like a bird, so it looks like a bird. So probably it's a dangerous animal. Probably if he's saying beware, probably it's pretty big, etc. So you can imagine something that looks like this. All right. So lexical semantics is about this. It is a word that we know nothing about. Probably there are other words like jub here, and you want to infer from the context in which it appears the semantics of this word. Like what does it refer to exactly or approximately? All right, so we have to talk all the time about similarity and relatedness. All right, so they're not the same thing. So for example, we can say that fast is similar to rapid and speed. So they have something to each other. They share a background. They talk about similar things. In the same way, tall, high, and height are similar to each other. Why is this important? Because if you are doing something like question answering, and you have an engine to which your input is a question, like this one, how tall is Mount Everest? And you're gonna have to find many candidates' answers and then choose the one that is the most likely to be true. But if you just look for passages of text where the word tall appears, then you're gonna miss on passages where height is used instead of tall. So you need this similarity because this similarity will increase your visibility of the passages that might include the answer. You can think about the same thing, for example, for information retrieval. If you're looking for a document, then you might not see a document if it's using a related word or similar word instead of using the word itself. In the same way, we can say that, for example, cat is more similar to dog than it is to table. In table, on its turn, is more similar to chair than it is to dog. All right, we can complicate things a little bit more and can say that run and fly, they are two pretty different actions, but they are more similar to each other than they are to think, which doesn't involve any movements or a spatial direction or anything like that. So cats, in a way, is also more similar to meow than it is to bark. So when we talk about similarity and relatedness, we talk in this sense. Like, are these things similar to each other, related to each other more than other words, right? Okay, so why are we doing all of this? We're doing all of this because when we started this course at the beginning, we said, well, if you want to represent a word, one of the ways in which you can do it is that you can do a one-hot vector. One-hot vector, so in this case, let's say that I'm talking about the word fish and I want to represent it. What I'm going to do is I'm going to create a vector that has the length of the size of the vocabulary. So let's say that I have, I don't know, maybe 100k words. After I have processed all my corpus, I find 100k unique words. Okay, now I want to represent the word fish, And in order to do that, I'm going to create a vector of 100k entries, and then all of them are going to have 0 as a value, except for the index corresponding to fish, in which I'm going to put 1, which is why it's called one hot vector. All right, what is the problem with that? Or what are the problems that we have encountered so far in the course? Okay, so one of the things we can talk about is this size here. Okay, so 100k is quite a lot, and as we have seen in the course, sometimes you want to use bigrams, trigrams. So if you are using features that include unigrams, bigrams, and trigrams, then you can imagine the size of this thing. It's going to be huge, right? And we're talking about one word. So depending on the application, you might need to process more than one word at the same time. But the other thing is, if let's say that my corpus says, I love cats, I like dogs, and then my vocabulary is going to be I love cats, like, and dogs. So this is how many? 1, 2, 3, 4, 5. Okay, so the size of your vocabulary is 5. Then let's say that I want to represent this first sentence here, S1. S1 will be something like this. It's going to be 1, 1, 1, 0, 0, right? Because the first word I is present, second is present, cats is present, like and dogs are not here. So if I do S2, it's going to be something like I love is not there, so it's 0, cats is not there, so it's 0, like and dogs are here. Okay, so let's say that you are using this actually for training. Now you come to test, and your test sentence ST is I love horses. All right, so your ST is going to be represented something like I love, which is 1, 1, and then the rest will be 0. So if you are doing this for some kind of classification or something, for your classifier, this representation is kind of strange. It has never seen this before. But mostly you cannot tell that there is some kind of similarity in between this and that, right? Especially if you do it on one word level. So if you do this and you say, this is my representation, and then you have a 1 here for fish, right? And this 0, 1, 0, 0, 0, 0 until the end is my representation for shark. Okay, there is nothing that tells you that this vector is more similar to this one than, let's say, 1, 0, 0, 0, 0 that represents table. Okay, so this one hot representation, whether you do it at the word level or you do it at the document level, it does not guarantee or promise even any similarity in between words, because 1 will be there where you have chosen the index of the word to be. It's not going to be that 1 here is closer to 1 here in index because they have some kind of similar, nothing like that. Which means that we have problems with unseen words, right? Because now you have an unseen words, it's not even in the vocabulary. So it's going to be all zeros, that's 1. But also, for the words that you have already seen in the training, they don't have any similarity. So if you have seen, for example, the word fish 1 million times, and you have seen the word shark 10 times, your learning is not going to be able to transfer anything from here to here because there is no similarity in between them. Okay, so this one hot vector representation has these problems. You cannot even see, for example, the similarity in between shark and sharks. Yeah. All right. So for us as humans, let's say that I invent a new word, tesguino, and I say something like a bottle of tesguino is on the table. Everybody likes tesguino. Tequila makes you drunk. We make Tequila out of corn. Okay, so I'm giving you properties of Tequila. You can already tell that Tequila is not something like an airplane, right? Just from these contexts, just from these words, you can already tell something like, you know, some kind of beverage, maybe a beer or a whiskey or wine or something like this. It's alcoholic because it makes you drunk. And from there, we're going to try to make a hypothesis and say that two words should be similar if they have similar typical word context. Two words that occur in similar context should have similar meanings. Okay, so in the next video, we're going to take it from here and follow up.